Alright, in this video we're going to look at verifying trig identities. And an identity, recall, is an equation that is always true no matter what the value of your unknown or your input. So for instance, we might have something like 2x plus 6 is an identity with the equation 2 times the expression x plus 3. So to verify an identity, we're going to work with the left and or right sides of the equation given to show that the equation is true for all values of the variable. In other words, that the left and right sides, although they may look different, are actually different sides of the same coin. So in this section, our identities are going to involve trig functions. So we're going to start with the quotient identities for trig, and we have tangent of an angle is the sine of the angle divided by the cosine of that angle. And that's true for any angle that we're taking the tangent of. It's the sine of that angle divided by the cosine of that angle. And this quotient identity, along with its reciprocal cotangent, going to come in handy throughout the course to know that the tangent of anything is the sine of that thing divided by the cosine of that thing. So we're going to verify that identity. We're going to show why the tangent of an angle is the sine divided by cosine. So here we have our XYR right triangle with theta in standard position. And if we look at the sine of theta is y over r. So we got y over r for the sine of theta. If we look at the cosine of theta is x over r. So we have y over r for sine over x over r for cosine. And we have a complex fraction here, so if we multiply the numerator and denominator by r, the r's cancel out and we'll get y over x, which y over x is tangent. So the tangent of any angle is the sine of that angle divided by the cosine of that angle. The reciprocal is very similar. We're just going to have cosine over sine, start with that. And we have x over r for cosine, y over r for sine. We're still going to multiply the numerator and denominator by r. And that's going to cancel out the fractions, and we'll have x in the numerator, y in the denominator, and x over y is our cotangent ratio. So cotangent is the cosine divided by the sine. So we also have our reciprocal identities where cosecant is the reciprocal of sine, 1 over sine. Secant is the reciprocal of cosine, 1 over cosine. Cotangent, the reciprocal of tangent, 1 over tangent. And likewise, sine is the reciprocal of cosine, cosine is reciprocal of secant, and tangent is reciprocal of tangent. So we are also going to look at what are known as Pythagorean identities, and these are going to be some of the most important identities that we deal with in this course, and they're based on the Pythagorean theorem. There's 3 different Pythagorean identities, and we're going to show where they come from in this video. So we're going to start with the most popular, where the cosine of an angle squared plus the sine of an angle squared is always going to equal 1. So cosine squared plus sine squared of any angle always equals 1. So we have this right triangle again, and it is the Pythagorean identity, so it makes sense we're going to involve the Pythagorean theorem. X squared plus y squared is r squared. This is another equation we'll be dealing with quite a bit in here. So now, if we, based on this Pythagorean theorem here, x squared plus y squared is r squared, each of the 3 different Pythagorean identities can be found based on what you do at this next step. So for this one, we want it to equal 1, which means we want this side of the equation to equal 1. So to do that, we're going to divide both sides of the equation by r squared. So if we divide both sides of the equation by r squared, we get x squared over r squared, which is x over r, that fraction squared, plus y squared over r squared, which is y over r, that fraction squared, equals 1. Now x over r, we know that as cosine. So x over r is cosine, we're squaring that, plus y over r is sine, we're squaring that, equals 1. And when we raise trig functions to a power, typically we put that power between the trig function and the angle. So cosine, that angle squared, we typically write it as cosine squared theta. Same thing with sine of the angle squared, we typically write it as sine squared theta. So we have cosine squared plus sine squared now always equals 1. So again, the good news is, depending on which value you divide everything on both sides by, you'll get the 3 different trig Pythagorean identities. Example 4, the next most popular one is 1 plus tangent squared is secant squared. So once again, we're going to start with x squared plus y squared is r squared. And now we're going to divide everything on both sides by x squared. So if we divide everything on both sides by x squared, we get x squared over x squared is going to give us 1. Y squared over x squared is the fraction y over x being squared. And then same thing with r squared over x squared. It's r over x, that fraction, being squared. Y over x is also known as tangent. R over x is also known as secant. So we have 1 plus the tangent squared theta equals secant squared theta. And we're done. All right, finally, our last Pythagorean identity. In the first one, we divided everything by r squared. In the second one, we divided everything by x squared. So this one, we're going to divide everything by y squared. So it's really just each of the three is based on what you divide by. So dividing everything by y squared, we get x over y, that fraction squared, plus 1 equals r over y, that fraction squared. Now x over y is cotangent, r over y is cosecant, so we have cotangent squared theta plus 1 equals cosecant squared theta. And that's how we can quickly come up with the Pythagorean identities. Some of them, like this cosine squared plus sine squared equals 1, we'll use a lot, so you will probably memorize it just based on use. So, but the good news is you can always quickly derive them based on what you want to divide everything on both sides of this Pythagorean theorem equation by. All right, so that about does it for this video. Thanks for watching. I'll see you next time.